recording. All right, so 10.4 is using Pascal's triangle, and the first thing I want to talk about is what Pascal's triangle is. This is an unending triangular array of numbers written by a mathematician by the name of Pascal, and he did this in 1653, but this actually was not the first time it was done. He's just the one who gets his name associated with it. That happens a lot in math, actually. But it was done much, much earlier by the Chinese and the Indians as early as 1100. Now what I'm going to show you first is the Pascal's triangle that, if you like Google Pascal's triangle, what you'll see. And then the second picture I'm going to show you, and we may or may not get to that today, is how it actually relates to what we're doing in this particular chapter. Okay? So are we almost done with writing? Are you close, Yael? Okay. All right, we're good? All right, so I know this is going to sound a little bit awkward, but I'm actually going to start by listing out some row numbers. And the first row, oddly enough, I'm going to call row 0. And as we work with this, you'll see why I'm giving it that name. But right smack dab in the middle of your screen, I want you to write the number 1. So the row 0 has one single number 1 on it. Okay? All right, now row number 1, directly underneath that, is going to have two number 1s on it. And they're going to be sort of on either side of the first number 1. Underneath them, but to the left and to the right slightly. We'll do the row sum at the end, so don't worry about that. That's a secondary sort of thing for us to look at. Row 2 is going to, again, have a couple more number 1s on the outsides of the number 1s we have, but it's also going to have a number directly underneath the one at the very top, and that number right there is going to be the number 2 in the middle here. Okay, so everyone sort of looks like it's off-center a little bit from the one line above it. Does everybody see that? But the overall shape that I'm making after I complete each row is a triangle. Okay, so hence the statement Pascal's triangle. Now I'm going to write a couple more rows and then I'm going to go back and show you how I'm creating the rows. Okay, so we're going to do row 3. Row 3 again has some 1s on the outside of the ones I already have. And it's going to have two other numbers directly underneath the two 1s in line in the second row, the row that's called row 1. So we're going to have a number and it's going to be 3 right here and 3 right here. Okay, so they're directly underneath the ones from here down. Let me do row 4 and then we'll talk. This is a 1 and a 1 again on the outside. Then I'm going to have a 4 and then a 6 and then a 4.
And these line up with row 2?
Oh, I think Mackenzie sees something. So what do you see, Mackenzie?
Oh, you added 3s to get the 6.
That is what it looks like, right? So Mackenzie's noticing it looks like maybe I added these two 3s together to get the 6. And she's exactly right. That is exactly how you get the next row. You add the two numbers that are above it together to get the number that's going to be sort of in the middle underneath them. So let's try all together to get row 5. It always starts with the number 1. But what would come next? 5 first, and then
You would multiply.
there's no multiplication. It's all addition.
Oh, wait.
10. Somebody said finally 10. 6 and 4 is 10, right?
Yes.
I heard 9s and 8s, but
2 10s.
2 10s on this one, and then another 5, and another 1. And you should notice there's some beautiful symmetry going on, right? Once I've kind of finished half of this particular column or this particular row, the other half is sort of the other image, right? It's just a reflection of the numbers. How about if we do 6? I'm going to start out with 1, and then what do I have? 6. 15, 20, because it's 10 plus 10, right? And then 15, 6, 1. Just for fun and so that everybody knows that they're doing the right thing, we're going to finish out the next 2 rows. Number 7, I'm going to have a 1 and then what? 7, 21, 35, 35 again, right? Right?
Yes.
All right, and then what? 21, 7, 1. All right, let's do one more row. 1, 8, 28, 56, 70, 56, 28, 8, 1. All right, so you can see why this is called an unending array, right? You could continue this as far as you wanted to. It would just continue the same sort of a pattern and get infinitely larger at the bottom, the base of the triangle. All right, so there's some beautiful things we've already talked about the symmetry, and you're going to look at some more of them in the group work, but I want to show you the row sum property just because it's interesting as well. So what I want us to do for the first few of these is we're going to sum across each row. So the first row is not a very exciting row. All it's got is one number on it. It has the number 1 on it. I'm going to put this far right because otherwise I'm going to run out of space. Okay, so this is a 1. How about on the second row? What does it add up to? Well, not the second row, but row 1, which is the second row. It's a 2. Then what? And then what? Let's do one more. What's next? 16. Now, we could keep adding up rows, but hopefully by now you've seen a pattern in what's going on with the sums. What's the pattern? Okay, so I'm hearing both features, which is awesome. So one of them, somebody said something about exponents, and somebody else said something else. Multiples of 2. Okay, so it's not multiples of 2, but it's multiplying by 2 each time, right? So if I can take the 16, what would be the next one? 32. Okay, so I can do 32. So if I know the row before, all I have to do to get the next row is just multiply by 2. And now these are all exponents or powers of 2, right? This is actually 2 to the 0, and 2 to the 1, and 2 squared, and 2 cubed, 2 to the 4th, all these wonderful sort of exponents going on. And we could continue this down as well. Let's go ahead and finish out the row sums for the rows that we have. What would come after 32? 64, and then 128 and 256, right? Okay, so this is really nice. We've got some interesting sort of features going on. We've got some interesting different sort of things we can notice about this, and you're going to see some others in your book. What I want us to do next time, and we will do it next time. Don't pack up just yet. Give me 2 more seconds, okay? What I want us to do next time is I'm going to show you a similar array. It's still going to look triangular, but it's not going to have those numbers in them, okay? It's going to have combinations in the place of each of them. And what we're going to do is we're going to relate combinations back to this triangle, which means everything you do in this particular section does not need factorials. We're not going to use any factorials in what we're going to do. All we're going to use is this triangle, okay? So we'll stop there.